Juan and Alejandro. Today we'd like to present you with an unprecedented revolutionary device that could change the future of transportation. With that in mind, as an engineer, our job is to improve and innovate different things for the better of the society and for a better, in consideration of the environmental impact as well. So our objective of the project for the Season Design project is to create something and use water as a supplemental fuel source. How do we do that? We created and designed a generator, hydrogen generator, that can be implemented in any internal combustion car. So by doing so, with using hydrogen, we'll be running a lot cleaner. Therefore, we'll be going green, as well as decreasing the amount of fuel consumption. So hydrogen, a little bit about hydrogen. Hydrogen is a non-toxic gas. It's a non-toxic gas that can be used to add as a fuel source in any internal combustion car. The car will be running cleaner, the gases will come out with zero emission, as well as increasing engine performance. How does it work? HydroGen generator. Our HydroGen generator works off of an electrolysis process. How does the electrolysis process work? It's basically a process that breaks down water molecule into its base molecule, which is 2 hydrogen and 1 oxygen. This is the process that it goes through. Positive anode and a negative cathode. While the electric current runs through the water, we'll have hydrogen and oxygen. So hydrogen versus gasoline. As you can see here, the hydrogen can burn up to 0.197 feet per minute, and gasoline can only burn up to 0.0295, which means hydrogen can burn a lot faster and be more efficient.
As for our main component, we have a battery isolator. What the device does is split the current from our alternator into 2 batteries without connecting the terminal together in parallel. And the second one is a pulse width modulator. And this device controls power supply in our electronic devices. In our case, hydrogen generator and the solenoid. The main component is electronic fuel injector enhancer. What this device does is read the oxygen from oxygen sensor, and it controls the mixed injection for hydrogen and gas injection. For instrument, we have a voltmeter. It measures the electrical potential difference between the 2 points in the circuit. For our project, we use for the batteries, and the ammeter measures the electrical current in the circuit, electrical flow current in the circuit, and the airflow meter. This device reads the airflow through the tube. And our project, we use HHO generator flow through the tube.
So as you can see, our circuit diagram is pretty simple. We have the main source, the alternator from the car, feeding the battery isolator. We don't have it here because actually in the car we took this yesterday, so we don't have time to take it out. Then we have the 2 batteries. These represent the main battery of the car. This one here represents the battery that you see here is the one that's going to take care of all the current flowing through the generator. Then we have a switch connected to a solenoid. The reason we have this is because we needed to have control since we're going to place this in the trunk of the car, we needed to have some control on and off switch from the driver's side. So that's why we use a kind of a solenoid, because there's no way we can run cables of 6 gauge, all that, like more than 6 feet. We're going to have too much opposition to the current, like at that time, so that's why we use what is called a solenoid. Then we have our PWM, that it controls how much current is getting to the generator, but by giving, instead of continuous current, it gives pulse, like we can set up the frequency of this pulse with this apparatus. Then we have the instruments, the ammeter. The ammeter has to be connected to the circuit. That's why we use a shunt. The shunt has the same reason as the solenoid. When you go DC current, it's impossible to run more than 10 amps through an ammeter at that far distance without like decreasing the current or have a misreading or burning the actual apparatus. Here we see the voltmeter. Right now it's not the one we have. The one we have is back here. Go back. That one is the one we use because this apparatus work with this device. We were able to measure temperature, pressure, and voltage at the same time. It depends on the way you connect it. Right now, at the beginning, we need it because we needed to know the pressure inside the vessel. But since we're not doing like what we stated at the beginning, what we read right now is the voltage of the battery. When we come to the design, we wanted to keep it simple as much as we could and cheap as much as we could. So we went online and we looked around and we found this vessel from General Electric. It's a household pre-filtration filter that is used in any house. So it fitted our properties, dimensions. Then when we had the dimensions of the volume of the area of the vessel, we went around, we used SolidWorks to model how many tubes can fit inside that vessel, and at the same time, the position for this vessel. After that, we wanted to keep the current out of the vessel for safety reasons, so we welded some screws on the bottom of those tubes, and we brought it down outside the vessel, as you can see here, like we did. For this, we use a CNC machine, so we can locate the points of these screws where it goes. We have, without changing any position on the vessel, we don't have any interference on the tubes. Here, it's just videos of after we did everything, our apparatus working. This is, play this one first, play this one. Play this one first. This one is showing the actual generator with distilled water. Right now we have no electrolyte in the water. You still can see some, you see it took a little bit more time to run because there is no electrolyte in the water, that's why the current is not flowing. Then when we add some electrolyte, play the next one. Then you can see, when you already play it, but you can see that as soon as you switch it up, you can see the flow of the hydrogen in between the tubes. And this is just a video showing how much was flowing from the actual generator. That's the hydrogen is coming out from the generator.
Okay, delivery systems. In our case, we focused on two different types to deliver the HHO gas into the engine. We're going to call case A when we send the HHO gas straight to the injectors, meaning the fuel line will be shut off. Case B will be when we send the HHO gas into the air intake of the system. Case A. Case A is a very ambitious way to run to make use of this generator. During our research, we came across some people online that claim they can run their car only pretty much on an HHO generator, pretty much running it on water. We did this just to prove whether it worked or not. We are aware that it's a very ambitious attempt. The requirements for this are to have enough pressure and to have steady pressure going into the injectors, as well as to have an adequate air-to-fuel ratio into the chamber. Next. The results of case A. Unsurprisingly, this does not work. After we connected the hoses into the injectors, the car did not turn on. And after a few seconds, I think 30 seconds, the battery was already drained out. We concluded that it's because the pressure is not enough, and also because cars are programmed to run on a 14:1 air-to-fuel mixture ratio. And during our research, we found out that to run a car on hydrogen, you need a 2.1 to 1 air-to-hydrogen ratio. So that did not work for us.
These are some pictures that the assembly had to do in the car. This is the prototype we had. In order to go to the fuel lines, we had to pretty much take the intake manifold out and then close the lines, and then we connect the hose on one of the lines, and then we got almost 60 psi of that vessel at that point. We cranked the car for like 30 seconds till the battery died, and it wasn't an explosion at all.
So this brings us to case B. Case B is when we send the gas into the through the air intake, and in the combustion chamber, as you see in the picture, we'll have a mixture of air, HHO gas, and fuel. We are attempting to get more a better and cleaner and also stronger combustion inside the chamber. This brings us to testing. So how do we make sure this works, or this does not work, or this doesn't work? So we're going to test for gas mileage. When we drive the car, we're going to try to keep some constants to make our data more accurate. So we're going to try to keep the AC temperature constants, all windows are closed, tire pressure constant, weight of the car constant, and the way the car is run. The way the driver drives the car is also constant. So this brings us to the run. Control run, to see how much miles per gallon the car is getting without the HHO generator. And then an experimental run with the generator run. Pretty much fill up the tank, then you drive around, combination of highway and city miles, about 50 miles. Then you go back to the same gas station. That's why it's about 50 miles, never really exactly 50. Fill it up again, find out how many gallons it took, and then with knowing gallons and mileage, we can find miles per gallon. Repeat the same steps for experimental for the HHO1. These are our results. Without the generator, we're getting 19.4 miles per gallon. With the generator, we're getting an average of 24.2. This is an average of about 24% increase in mileage. And here we have data about graphical data showing a trend with and without. Another thing we wanted to take care of was to see if the airflow coming out of the generator was accurate. So we got the airflow meter showing about 1 liter per minute coming out of the generator. Also, and then we found some calculate equations online that pretty much quantitate the process of electrolysis and how much volume of gas you're getting out of the process. Here we get about 0.85 liters per minute. Sort of similar to this, we can account this error to the difference in density because this device is made to measure air. And clearly, we're not just running air; we're running HHO gas.
So this is our total cost of all the equipment included. It'll be around $589, including the labors and costs. Right? As far as safety concerned, we know that hydrogen is very flammable, so we would like to avoid storing it in an external tank. And we want to use the hydrogen on demand as it produces, use it in a car as it runs. So what other things that we need to pay attention to is that the heating problem. We have a problem with the vessel heating and the water boils. So we added an external fan, but at the same time, it was still having some problems, so we had to pay attention to the heating problem. And then when it produces hydrogen, we have to pay attention to the surrounding. For example, battery, a spark, or a leak, or anything that may concern our problems. Thanks. For the future design, we'd like to add an external radiator to cool down the water itself, and place another fan to cool down the vessel, and or maybe placing the vessel itself, outside of the car or some other places where the external wind speed can reduce the temperature of the vessel.
As for the conclusion, our case B, as we expected, it increased gas mileage from the putting the HHO in from the intake of the engine. It increased the gas mileage about 24%. As for our prototype, because of the frequent maintenance and the temperature of the boiling of the HHO generator, it's not suitable for daily uses. It's not suitable for daily uses at this moment, this prototype. At this moment. Thank you.
All right.
Thank you, Group 3. Questions? Dr. Tamonte.
The first question I want to ask you, typically when I see white smoke,
Yes.
that kind of means moisture. That means vapor. Do you know if your system was creating not only hydrogen, oxygen, but also putting vapor into your system, which would be a concern from corrosion problem, incompressible fluid?
Oh my God. Actually, we did a test that it wasn't like a nice test to show here, but it pretty much we got an injector, and we connected the hose to the injector. We applied some current, and we have 60 psi flowing through that to the moment to the injector, and we lighted a match to see because I had the sensor.
No, I understand you would have hydrogen. That isn't my concern. My
And
concern
and
is
the flame,
you're
the flame was-
sourcing moisture into
The flame
your
was-
compression chamber.
To add to that, yes, since the temperature is so high, we might be getting some steam out of that. A way to fix that would be to implement a bubbler into the tube to catch all that steam and not let it go into the air. But due to time constraints and funding, we weren't able to do that. Any other questions?
Is that it, Dr. Tamonte?
That's my question. Yeah.
I'm sure Dr. Basil will.
All right. This is probably the most dangerous thing that I've seen anyone do. I don't understand how you guys create hydrogen gas and just have it run and flow. I mean, as engineers, right? I mean, like, you guys are engineers. You're saying this whole time, I didn't realize you guys are just creating hydrogen and having it go into the air around automobile parts,
Right
right?
now, the way we're doing is not going into the air. It's just we got.
No, I know, but
hoses.
you guys showed these videos where you
It
have
was-
hydrogen gas.
It was
coming out.
everything was turned off. Everything was open. It was only 10 seconds
but-
video, and it's still. I know it looks crazy, but I deal with it a lot, and I've been playing with it a lot. And
I understand you've played with it a lot, right? You just said you lit hydrogen with a match, right?
I needed to know somehow that what I was creating was hydrogen, and I don't have the resources.
I understand that. If you don't have the resources, that's one thing, but you cannot do this, all right? You can't do that. I mean, if you don't have the resources, then you have to find other ways to do this sort of thing. You cannot light hydrogen, right? I mean, this is a senior design project.
We're in a controlled environment, you know, where.
You're in a controlled environment lighting hydrogen, that's what you're saying to me?
That the proof wasn't control. It was a crazy moment,
All right.
a frustration moment that we needed to know that we were at the point that we were shooting inside the vessel, inside the engine, 60 psi of pressure, shooting through injectors, and we had no spark at all. We had the same problem. We at that moment we thought that we were creating steam, no hydrogen.
Right.
That's why there's no spark. So we needed to prove it, and that's at that point with the resources we had, that was the only. In order to keep going, that was the only way to try. And
Okay, but I understand. Again, the whole point of this is learning experiences, right? You cannot do that sort of stuff. You
I
just
learned
can't.
that. I learned
Right,
that.
okay, so we all get that.
Guys, let me just throw a quick example. I was in graduate school, we had a hydrogen furnace that someone forgot to turn on the burn-off stack on. It was at elevated temperature. The furnace went to cool down. They hit the explosion point on hydrogen, and they put the whole furnace through the wall,
Yeah.
through a concrete wall. Almost killed somebody. So his concerns are real.
Safety.
Don't underestimate
I
those.
understand.
Especially
I've seen enough videos of hydrogen is capable of, and really amazing. But like I said, it was a frustration time, and we needed to know somehow to keep going, to keep working on this, to make something happen. That was the only way at that time. And
Okay, for everyone else listening, I'm being serious. This is senior design, it's not kill yourself. Right? I understand there is some pressure for you all to finish projects, but do not do this, all right? This is a very serious concern, because we as a program, Alejandro, if you blow yourself up, you know where they're coming, right? They're not gonna come, they're not gonna say, oh, Alejandro, he's goofing around, oh, okay, well, next up. They're gonna say, oh, he's working on his senior design project and he's using hydrogen and he's lighting with a match, all right? Again, I don't want to reiterate this 500 times, but you can't do that.
As a segue to that, did you include that in your written report?
what the trial we did, of course not.
All right, so completely separate from all that. So, completely separate from all that. Going back to the actual, somewhat realistic test where you have everything confined in one small space and you're just making a small amount of hydrogen, right? You guys ran 5 different tests or 5 different specific tests where you were trying to compare.
We did a lot of testing and we got a lot of problems.
So can you go back to that slide?
Yeah.
Of
We had a lot of problems with the apparatus. That's why we added a fan.
Sure, so one more, yeah, okay. So you
just
ran 2 separate ones, right? One
valid
with,
data that
one
we
without.
had,
Right.
that we so we can show, because we have a lot of data, but then it was on and off because it was getting hot faster than at
Right.
that time, and since we used the car for
So you probably ramped it up as high as you could go to get as much hydrogen out. And
No, it was
then
it was
became
always
very
it was
hot,
always
right?
we got the control here and the apparatus, so we know how much
current that's
how much
flowing
current is
through
flowing,
the-
and we always keep it within 30, 40 amps.
Okay.
We started at 30, when it's heating up, you got more current flowing through the water, so you got more amps, you know, so it showed, once you get to 40, 45, we needed to turn it up, because it was already, it fried, the PWM was fried twice. We gotta change the transistors in there twice, because of this reason, so that way, we needed somehow how to control it, so we keep it always like that, but then there's more data that we didn't include because of that reason. It was getting so hot that that moment it was only, you can see it here, instead of having the bowl just running one, it was running all the way to the top because the density of the water was heating up, it was boiling water, so we stopped it at that time, and then that data, we gotta throw it away because it wasn't in hydrogen at that time. So this is the most accurate data we have, just running for like 10 miles, 20 minutes, stopping, another 20
So
minutes, stopping.
there's my question, right? Is this sustainable results?
That's what
So
we said.
what do these even mean?
That's what we said, that even though that
So you
we-
run 5 miles and the thing probably would melt your trunk, so you
that's what we
stop,
said at the
right?
end,
So are these reasonable results?
that's what I was
Okay.
saying. Even though we got some increase, we don't recommend this to anybody right now
Right.
because this prototype is not working for what we want, for what we stated at the beginning. It wants the increase of mileage. It has to, too much work has to be done on it, too much maintenance, too much change has to be made in order to make it like feasible and to put it in the car.
Yes.
So
We
again,
understand that we did a test and that's what we got.
Right.
We don't believe in this anymore.
Okay.
I mean, in this prototype, if we gotta have more resources, there'll be more money to work on this a little bit farther. Maybe gotta get a computer, set the injectors, the way the time of the injector. Maybe we could have get a little bit farther than that,
Right.
but we couldn't because that's you can see how everything is homemade. Everything is you can get everything either in the internet or in a local store. It's not anything is just.
To add on to what he's saying, we predict that this will actually not be constant. It will probably go down as you use it.
Yeah, I mean, if you're doing it for 5 miles
yeah.
and stopping,
It's
but,
not-
I
it's
mean,
not
and
reliable
on
at
top
this
of that,
point.
I mean, it's certainly not a controlled test. You basically fill up your gas tank with some gas and then you drive a little bit.
Oh, we always
Yeah.
try to return to the same gas station, like because
Sure, I mean, all gas is pretty-
it was used in a car that was easily, I mean, used in the daily commute, so
Mm.
it wasn't stopping at time. At the time you stopped, we threw that data out, and then we had good data during the 50
We're-
miles. We control everything. Then we out of here.
Not-
This
But
been
there's so many
for a
things that go
month,
into gas mileage,
Exactly.
right?
That,
So,
that procedure shows the constants we try to are the ones we can take
Yeah.
control of. There's
The
obviously things that are out of our
Temperature
use.
was,
Sure.
That you
I
can only
understand
take-
that.
so let me ask you guys this then. I'll do one more question.
Yes,
What does
Dr. Basil,
GM,
just one more.
Chrysler, Ford, sorry, what does GM, Chrysler, Ford, how do they measure gas mileage? So when I put a sticker on the side of a car, how do they measure gas mileage?
Well, now
They run
You wanna take
control
one of
tests
these down?
on labs.
You know what
Yeah,
that
they
is?
don't have access.
Okay, so what kind of control tests? What do they do?
I'm sure they run cars
You're
constantly on a dyno.
You sure they run a car on a dyno?
That's what.
So you didn't investigate actually
We
the
did.
highway
Different
standards?
companies do different tests. Some companies are now actually doing the test of the car by.
No.
driving
So
it.
Federal Highway Safety Administration has a specific way to measure miles per gallon, right? Did you guys look that up?
Well, what I found out was that some companies.
Well, answer his question.
Have you looked up that standard? There is a standard way to
For the-
measure gas mileage. Did you guys look that up?
that what we looked
Not
for
the
was
first
they.
Answer his question, yes or no?
We did, yes.
Okay.
Okay.
He did some research, and we found that they actually put like 4 people in the car, and they're like nowadays that's what they're doing. They're running people in the car in a truck for a certain amount of time and that's what they're doing now.
So did you try to replicate that procedure or no?
No, we tried, but that's
So
what
I talked to you guys about this for
we
6
gotta
months.
understand what we have. So
No,
the only
that's
the only
perfectly
way
fine.
we know how to do it. It would have nice if we had like a bench engine that we can set the RPM and have some speed and some temperatures and control
Alejandro,
that.
listen
We
just for a
didn't
second.
have
I
that.
understand that you don't have the perfect setup, right? But the whole point of this is to get as close as you can. So what we would like to see for everyone in the future, and then I'll stop, is this is the standard. We couldn't reach that standard, but we did these 10 things that were as close as possible to that, okay? We understand you have cost limitations, but if you can say what you would have done, that's much more important, what we would have done if we had the money, right? That's all. All right.
Oh, right now, just let me add something. We use the car, and the purpose of this is to run in a car,
Yeah.
to save some mileage, and it's
That's
gonna be in the daily commute, so that's how we test in the daily
Right.
commute, to see we have some increase for the user,
Yeah, that's fine.
anybody.
I'll let anyone else.
Okay.
anyone else.
All right, well, thank you very much. By the way, Dr. Basil, were you the advisor?